statistic. Why it's called descriptive? It's because it comes from the description. You want to describe the spread of data. For example, I have a data over here. This is the data I measure. Of course, this is the line, the thing I measure x, So I use 10 tabs to do the measurement. So then the guy do the measurement for me. He do all the measurement over here. In total, there are 10 points he get. So now comes the problem. I give you 10 tabs, and you give me 10 numbers. Claim the position, the length between A and B. Which I'm going to take tab 1, tab 2, or which one? So no one. I can't take just one tab. I will tab. You take the mean. So basically, simulation. You assume the 10 tabs. 10 tabs they have a mean. This is a mean for the so this is a mean for x. Basically, this is a mean for x. Normally we use mean bar, x bar to indicate it's a mean. You can this is x1 plus x2 up to x10 and divide by 10. So this x bar can be easily calculated. There is no problem. Now the other one. So this basically is called descriptive indicator. Indicator what? Indicate the distribution of. So suppose this one you calculate this is the mean. So basically it means based on this mean, all the other numbers they are just walking around this mean. So that's the spread. We call the spread. The mean indicate basically just by its name is called mean. So it means it's not too extreme. It's neither too extreme. So it's just the mean. Okay, so that's one thing. One indicator. It mean to. The other one we are much more interested in is about the other data from this mean. Because we are for example we are interesting in what? Now I assign one person to do this. So this guy get all this information for me, right? This is just one guy. People what? Okay, now I give the 10 tabs, identical 10 tabs to that person, to other person. Tab 2. This is another one, another person. 2. Okay, so this one is going. This guy is going to do the measurement for me. So he's going to measure 10 times based on different tab. You have 10 tabs. So he measure 10 times. Okay, very good. So again, he get from this 10 times. He also get mean as well. Divide by 10. So now the question we are going to ask is. For one thing, you have a kind of controversial now. Based on the much more information, the more information we have, the better, right? Measurement, because it's a measure much more accurate. If everyone says this is a white object, then we believe it's a white object, right? So it means if more people measurement, more tests do the measurement better, right? How comes from? You have too much information. For x1, you have 10 data. Each data might represent the real one. You can take each data, but which one am I going to take? No way, you're going to take the mean one. Okay, the second one, you also 10 data. Which one are you going to take? You don't know. You might take the mean one. But is the mean one going to the reasonable one? If there is no real one, the reasonable one. How are you going to do a comparison? There is one way is called deviation. Deviation measures you have a mean over here. How about others? The distance between these the other 10 points. The distance between the mean and the other 10 points. And but there is one problem. What's the problem? if you adopt the distance, I mean, in a way, if for example, like this point, the larger this one, right? This point, for example, suppose your measurement over here, I get rid of this one. This one is it's supposed based on the axis, not on in air. So I get rid of this one. This one. Okay. So all your measure is supposed to lie on the x-axis, right? So the x-axis means the position between A and B based on the tape. All right. So you can take a look. This is our mean. This is our mean. And how about, so if at this point you have a higher point, so you have get the distance is positive. This point, the p distance is negative, right? You have a low, you are under bar. Suppose this is a bar. Our mean is a bar. This is also over bar. Above bar, this is under bar, and if you take them all together into consideration, if you adopt just this approach, you cancel them out. This have a higher, this have lower, you cancel out. So in this case, I cannot see the distribution of the data. So it might be in these 3 points in the over here. There is some result as these 2 points is spread over here, right? So, but this as these 3 points are spread is much more inaccurate. It means that I can't trust it. If the 3 points all here, you can trust it. So in this case, you can adopt this approach, like cancel this. So what are you going to do? You are going to square them. Square this one. Square them over here. Let me use this one. You are going to square them. That's the reason. Some people, they don't use a square. They use absolute distance. It means distance between this one and this one. So this one was, for example, distance 2. This one distance 1.8. So the absolute distance between these 3 points, suppose that this is mean. So the whole system, the distance between this one will be the absolute value of each one. So now become 2 plus 1.8, 3.8, right? 3.8 plus other point to this one. So it's called absolute value. We call absolute distance. And you might wonder, how come people don't adopt this absolute distance? Some of them adopt it. The reason for not adopting absolute distance is very easy. It's hard to calculate because we prefer to use something you can use calculus, or we call advanced mathematics. You can do some calculation or differential integration, this kind of tools. If you use an absolute value, it's very hard to apply this kind of tool. That's the reason people prefer not to use absolute value distance to measure the distribution, the spread of the data. So if you have a low spread, if the concentration is higher, you have a lower one because everyone is very close to the mean. It means that the data is very centralized. So in this case, if a low error, every data is very close. If you trust the mean, you make less mistakes. But so you can do a comparison. You can compare which people I can adopt. Am I going to adopt one or adopt two? If the measurement for adopt one spread too much, it means maybe he have a stroke. His hands keep on shaking. So this guy have a problem measuring other things. So how am I going to trust this guy? All his measurement is the data highly spread. So it's too much. In this case, he probably prefer the second person because the data is much more centralized. It means it's much stable. So that's one. As a client, as a surveyor, chief surveyor, you have some people working for you, people to working for you, but you have to decide the distance between A and B, which maybe you can. Second one is okay, but he much more stable. His distance is not stable, so the image basically I can trust it. So you can take the mean from the second person as the you use is mean of the mean. I mean, you can take mean of one person, and the mean of the second person. But you must give something called weight. just give the whole idea. We'll do the details little by little. But now I give you the whole thing. Give you the weight. What do I mean the weight? Weight means the trust. The trust. If you trust person one, because a person one might be a person. He might do the measurement, or he is much more professional. He been doing for like 10 years or something. And he's just a freshman. The second person is a freshman. In this case, I might put a weight. This one weight probably is 2. This one weight probably is 1. To indicate his data is much more trustworthy. So in this case, your mean, this mean will times 2 plus 1, the mean times 1 divided by 3. Then you can get an average based on mean, based on weight. That's another way. So there are ways. There are many ways you can choose but you got to make it sensible and reasonable. You can't say you can't just say, okay, I just blindfolded and then I randomly pick out one and I say take out his result as a result. No, you can. So of course, you want to make an absolute much more approximate the true value. You probably have to hire more person rather than just 1 and 2. Maybe you have to hire 100 person to do the if A to B is very. We have to hire 100 person to do the for you, and may have to change as well. Maybe assign different table, maybe 100 accurate. So let's take one. So error is a distribution. It's a distribution. So it's called standard deviation. A standard deviation, and why it's called standard? Standard basically your deviation just the numerator bit. Denominator is you have to make it standard. So make it unit. So for example, over here, 10 points over here. If I do the square distance between one of distance between this one and this one, and just square them up and add them together, it will become a huge one. But we don't care about. I just care about the on average. On average, what's the standard deviation? On average, what's the error? So in this case, you divide by n here. So here, take a look. Here you have a mu. Over here, mu over here. This mu is a population mean. Population mean. Do you know that? Probably not. And this some exceptional case, like the previous one, I had or something already know. So otherwise, population mean normally is unknown. It normally is a population mean. Population. Some case, yes, you know, if the population is hence. Some case is unknown. But most of the time the population is unknown. Anyway, how about this x? X is observation. So I prefer to write xi, not x. I prefer xi. You do the observation. How many observations do you do? You do n. So here you have a summation. Summation over here. Starting must from I1. In this case is 10, but since we are producing formula, so we don't produce say 10 with n. How many samples or how many times you pick up from this one? So this you have 10 over. So this one produces xi. So mu minus xi. So it's you can just write it as mu minus I. So yeah, I over here. So this one is called standard deviation. Standard deviation of what? Of the population. This population. So in this case, this will be a mean. This will be mean over here. Population. If the population is already known, this one is okay. So what's the meaning of this one? It's called sigma n. N represent the times you pick up. If the population is known, and I pick it up for how many times. This n is how many times you pick it up, and then you get a derivation. So divided by n. Without dividing n, it means what? It means the total derivation. Without dividing by n is total derivation. But we don't care about total derivation. Why? Because we want to do comparison. For example, if we did a pinpoint here, and then the second one, I ask him to, I give him the 20 taps rather than only 10 taps. So he is going to produce 10 observations. So this person produced 10 observation, and this one produced 20 observation. How are they going to do the comparison? Very hard. So in this case, we have to divide by n. Then I can get the average derivation from people 1 and average derivation from people 2 in a comparison. That's the reason you divide. Otherwise, this one is if you have 20 taps, you pretty much is to get higher derivation, So you standardize them by n. This one probably by 20. This one by n is 10. So you can do the comparison. So this you get an average. In some sense, you can treat it as an average error from what? From mean. Average error. Average error. So average error. Okay. So this one you can treat as an average error. So this average error is the less the better. It means your the measurement is very concentrated, and it's much more accurate. You can do much more on this control. If data is much more centralized or concentrated, is put a much more weight on possible. And this one, just like I say, could you produce the standard deviation all the time? No. Why? It depends on the population. If you know the population, good. You know the population. You know what do I mean? I know the population. Basically, we know we mean. You know the population means that you know the mean, or you know the distribution of the population. That's the reason. That's the meaning. Knowledge, the knowledge. Otherwise, you don't know the population. You don't know. When is it going to rain tomorrow in your country? During the 24 hours. Who knows? No one knows, because it's highly influenced by the gravity, by all sorts of influence. So it's hard to tell by the atmosphere as well. It's hard to tell or even predict. So weather forecast, it's just predictive, but it's not accurate. It's just it varies as well. Okay, so in this case, if you still reasonable, if you think it's reasonable, we check if the error is low and the data is much more trustworthy. Is reasonable. But it seems you cannot get this one. You don't know the real population, so it's sort of like you cover your eyes. So if you cover your eyes, but you still want to have a mimic this kind of knowledge, we call the mean. You still want to do this kind of want to know the data, the spread of the data, the real situation spread of data. Yes. You do this one, the second one. This one is called the sample one. This is called the sample. Probably here, probably don't have a name for it. This one is called the sample standard deviation. Sample one. These are people don't give you a proper name like a population standard deviation. It's quite lengthy, wordy. So normally, multi. So normally we just call it the standard deviation for this one, but this one called sample standard deviation. Okay, and now what is x hat? X hat basically if we look at this one, probably there is a problem. I think here you see the inaccurate notation. X hat supposed to write this way. This not this one. Not here. Over here. Over here. Previously, we were talking about this one is basically for the human interact with the machine to make observation. But here that doesn't. It means the mean. It mean. Okay. How do you calculate this mean? This mean comes from the sample. So supposedly you measure. In this case, this case is much more representable if you use on this case rather than this one, because this one I don't know the true distance between A and B. So even I do the measurement, I don't know, because the population, I don't know population. The real one, no one knows. So all I can say is I have the data. I get steps divided by the 10 steps observation of 10, and then divided by 10. You can get X bar. And then you X bar, this is a X bar, this is an X, this is X bar. I change it to X bar. Okay, so X bar, and this is a X is a XI. So in this case, previously we were talking about in this more like talking to this kind of case. Like X bar here is this one. I have 10 observations, so this is X bar because we don't know population. So this X bar base, this is a base. If you know population, if you don't know the population, this X bar is over here is X bar, and XI. So XI is every point over here. X point you have 10 points over here. So this is again this is the total distance. The total numerator bit is a total distance, and like I say, we don't care about total distance because the total distance varies because you have a different observation. If you have more observation, you have more total deviation. So we care about the average one, average for the sake of comparison. Okay, so now you have to divide by, in order to get an average, you have to divide by is the number of the samples. But hold on, you might wonder why is n minus 1. Here is n. You might say why is a mistake, a typo one? No, it's not a mistake. It's divided by n minus 1. Why n minus 1? Why? Because this one normally we write this way. Normally this one is for sample. This was a sample. The standard based on this sample. Anyway, so this sample. This one divided by minus 1 is knowledge of statistics. We call the this one. You just hear what I say. Maybe you cannot really understand very much, but you just listen out and then hear it out and then get some knowledge, impression. That will be enough. So basically, this S, we call it estimator, statistic estimator. Sometimes we even call it random number. So from the point of statistics, without really going to the observation, this itself is also an unknown things. Of course, if you really do the calculation, not calculation, the observation, you get a real data. So this is called realization of this random variable. So this one, without really do the measurement, is already here. It's a mathematical formula. It's already here, right? And this state, you want to make sure this X can stands for can represent this one, sigma. You can represent this one. So, but it's a probability. There's a probability chance here. If you look at the X bar do the measurement. X bar itself indeed is still don't know. If, for example, if you 10 numbers, this take another 10 numbers, then I produce different one. The realization are different. Theory. This is a theory. I do the calculation together divided by 10. So what are the 10 numbers? Who knows? I haven't done the measurement. So this one, if you don't do the measurement, it's a theory. It's a theory over here. So we want to make represent this one. approximate, reasonably approximate one. So in this case, normally in this case, we call it unbiased. Unbiased means overall in the long run, approximate this number. And because I don't do the proof, so you can't see why we cannot do the proof because that will take another 1 or 2 hours. So all I can say is that n-1, there is a 1 degree. We call 1 degree of freedom difference. So if you divide by n-1, this x will approximate in the long run. I can't say in the long run. Probably on average is better because the probability on average. On average, this one will reach this one. On average, will reach this one. If you divide by n-1, if you don't divide by n-1, you have a bias. You won't get on average. You won't get this one. So anyway, just take it as a face value, and remember this one is called sample deviation. Sample standard deviation. We use this one very often. As a surveyor, you use this one very often. You already use this one because you don't know the population. If you know the population, why bother do the measurement? So it's kind of like the what's called the contradictory, right? So it means that you don't know this one. In principle, you don't need know this one. All you can do is use this one to approximate this one. But you might wonder why this one is so important. And average error is important. Of course, is you know the average error. Is an average error too huge? To some degree, you shouldn't completely abandon the measurement. For example, if the measurement is all the temps you have the measure or differ to some extent, a huge one. It means that the people still have some problem. All the taps, 10 taps has some problem. Maybe it's already fatal in some degree. So you cannot trust the taps or the person. So you have to ditch the measurement completely altogether. So this is important. We want to make sure our deviation, the standard error, is reasonable, is a low one. If it is too big, too huge one, it means that your measure is has some problem in your measurement. Otherwise, A, B is fixed. How can you all the 10 measurements so differ? They might differ a little bit because check a little bit, but not so much. It's not so much. So you can't have a huge divergence between them. They're supposed to be very close. Okay. So it's called this one is called a standard error. If you like, you can also call it standard deviation. But standard error probably is much more accurate to capture the intrinsic meaning of this one. Because in this error here, the denominator, the numerator represent the error, the total error, right? From the mean. This is our mean. They are mean. So the spread of the data divided by n-1 is the average. So this is a standard error. So this is very important. If this number is too huge, it means your data is unreliable. Either from your observation or from some problem, your data is unreliable. So that's remember is very important. Okay. Now let's come to the next one. Next one is called variance. Variance is nothing. Basically just taking the square root. Is variance is over here. So variance is m-1 square. You go with by the way, you might wonder why there is plus minus. Indeed, it's come from this book. Probably is in different order. I think it's supposed to variance for. Because it's supposed to come from the variance. You have here, you have a number here. You calculate some number, and then you can get a v. V square equals some number. Equals the number by this is this number is this number. Now they are the same. And then you have is a square one. Sigma square equals this number. Sigma Now you can get sigma is over here. Sigma n minus 1 or sigma is a plus minus square over here. So this normal because you don't take all positive into consideration. Sometimes they might direction. Now you always sometimes the relation is unchecked. So you do plus minus like a package of like chip. The package of chips plus minus 5 grams. So that's it. So okay. So and next one is about state deviation. This one even much more. This one reading just one data. You want to get one data. You want to have a data, but the thing is X bar is unknown. So the next question, you are going to estimate the X bar. X bar. It's called standard deviation or mean. Sigma m. So each data you are going to estimate the X bar. So estimate mean. So it becomes the mean of the mean. So, for example, you must say, for example, my question might go like this way. My question is, what's the average score in Siever's vein? So in this case, I care about the average of Siever's vein, but it's also unknown because you are asking about average score of you are not talking about the score of one person, a single one, or you are talking about the average score of the whole class. So itself become a new random variable. We are going to estimate this one. So next time we'll start from here and start. Later on we'll read some calculation. Now we know about theory, and then you'll have a lot of theory, a lot of calculation goes on. We'll get the major one. You look at this one. You have a major like a 10 text. Weight. So different kind of weight. W is X. You get this one. So next time, hopefully, we'll get to some simple example based on all this knowledge, and then you have some concrete and crystal idea about the whole theory. And so far, you only have to remember the idea is tackle this one. This one is a main one so far. The sample, we call it standard error or the sample standard deviation. Okay, so we put it today because is it a lecture always? We still have 10 minutes or is the end of the lecture? Who can respond? I'm asking, is the time up or we still miss? The lecture is 4 o'clock or 4:10. 4 or 4:10. If we have 4, we have to stop over here, but we have a 4:10, then we can continue. But anyway, I'll check it out. So let me see the we have to make over here as well. So now we have some of you, I think they just joined previously only like people, you know. So, okay, 4, 5. Okay, so in this case, I'll just grab the screen a little bit, and then for you to take a look. It's not completely accurate, but I just make sure you are here. Hamilton. Okay. That's the one. But unfortunately, you cannot talk, so you can only. So what I'm going to ask is a very important question. Am I talking too fast or too slow for you to grasp the whole idea? So give me feedback. whether it's a proper proceeding, or you want me to go faster or little fast. Little fast means I should go a little bit faster, or I talk too fast. You can understand. Yeah, you can understand. It's good, but I'm just asking you: is a proper one, or you prefer like I should go faster, or you prefer like slow, or what? Of course, this time probably doesn't count because next time we will come to the exercise bit. Then probably have some concrete idea the whole thing, because now we are still building up the whole theory. So it might go a little bit slower because I try not to confuse you guys. This week probably we don't have a homework because we haven't reached the exercise date. So next week we'll have assign you guys homework, but this week we don't have a homework. But it's better you can pick out a book and check uh, what I told you guys, and then do some revision. That will be better. Okay. Any other questions? Any questions? Any kinds of question? That'll be fine. Any feedback? Any question? If you are here, I suppose to get me some feedback. Otherwise, maybe you are not here. You are just. Your name is on that list. Sometimes it's okay with me. Okay. Okay. So for the attendance, please to your class leaders, and the class leader, please record it accurately. Don't just if they don't come, just record it. They don't attend. Otherwise, they stop coming, and that cause some huge problem. Don't worry. If your name is not on the list, please tell your class. If you tell him now, he trusts you. If you tell him tomorrow, he's going to write you down. You are absent. So please tell him now. You are in a class, but you are not on the list. So he will do the consideration for you. Okay. So if there is no further problem, then we'll just call it a day, and I'll leave all the attendance bit to Hafiz. And by the way, if you want to have a copy of today's lecture, and I beg Hafiz already done the recording one, so he can upload to somewhere. You guys are for much more familiar, and then can go there, or you can simply ask is to write. To send you a copy, and then you can look it again. And it's good if you can just collect all the our videos, everything. Then in the end, if you want to take a look or want to do some revision, it's easier and fast. Otherwise, you probably can't remember anything. Okay. Then. Okay, we discuss and please out this room within 10 minutes. We are going to have another class. Of course, if you are interested in our another class, you are more than welcome to join. But otherwise, please log out in 10 minutes. And okay, then see you next week. Okay. If you have any problem during this week or this weekend, you know, we can sort out anytime. We don't have to wait until last moment. We can sort it out. Yeah. Okay, bye.